네, 안녕하세요. 저는 CSS를 제일 사랑하는 후이징입니다. 반갑습니다. 아쉽게도 저는 한국어를 잘 못해서 영어로 말하고 있습니다. To the translator names in the back, 잘 부탁드립니다. That is my name in Hanja. I'm not sure how it sounds in Korean, but I'm guessing the pronunciation is a bit different. I'm not a complicated person, so these emojis pretty much cover who I am as a person. I also have a day job with Shopify as a senior front-end developer because I like being able to pay my rent and stuff. So today's talk is focused on CSS because if your content is going to be rendered by a browser engine, then your main mode of communication with the browser for styling content has to be CSS. Now, browser engines today are much more capable than before, and they can lay out content much better than before. So it is in our best interest as web developers to know how to make full use of the browser's web layout capabilities. Now, a major issue with web content is that your users could be using a screen as small as a smartwatch face or as large as a 70-inch HD TV, and you, as the developer or the designer or the creator, you can't control this, which means that the way that we think about designing layouts on the web cannot be like anything else that is fixed. It is a different mental model, and the tools that we use must suit this fluid, interactive medium. But luckily for us, now that Flexbox and Grid are well supported across all the major browsers, our toolbox has been greatly upgraded because both these layout models were introduced after the web had evolved into more than just a document viewer. They were built to handle application interfaces which would be viewed across many different screen sizes. Now, admittedly, Flexbox had a relatively rocky rollout as browsers implemented experimental versions of the syntax before the specification had been nailed down. But by 2015, the major browsers had updated to use the latest spec, and the implementation was very stable. So the browser vendors and specification authors, they learned from the Flexbox rollout and developed Grid behind a feature flag instead of using vendor prefixes. So Grid was rolled out in a very coordinated manner in 2017, with the 4 major browsers getting it in March, and by October, even Edge and Samsung Internet got it. So we fast forward today, 2022, the percentage of internet users surfing the web with browsers that support Flexbox and Grid is overwhelmingly high, way past 98%. So browser support is no longer a valid argument for why adoption rates, I feel, are lower than expected. Honestly, Flexbox is everywhere because it has become the go-to for web layouts. I've seen my 1,000th how to center something vertically with Flexbox articles, so I'm not surprised that it's so common today. But even though this survey is relatively small, about 8,000 developers, it still prompted me to wonder why the Grid usage numbers are not as high as I expected. Now, among the 13 links I have in my bookmarks bar, I could only find Grid usage in CodePen, Discord, Inbox, and Spotify, and only Spotify really embraced Grid as a page layout tool. They even use named grid areas. JavaScript was introduced in '95, and a few years later, the concept of AJAX, which stands for Asynchronous JavaScript and XML, started to take off because it allowed content to be updated dynamically without reloading the entire page. And this is what single-page applications, or SPAs, are built upon. That's the concept. But the term single page feels very misleading because the single page of a book doesn't feel very large. But if you think about a lot of the SPAs out there today, it's more like a page the size of this room. So it's like SPA. And with this increase in scale and hence complexity, the organization of code becomes a lot more crucial. So we turn to frameworks because frameworks can help provide structure. But with frameworks, there are some restrictions on how to do things. So maybe that's another reason why Grid is not so common. But first, let's do a quick run-through of how grid works and how to use it. Very similar to Flexbox, it involves a parent-child relationship between a container and its immediate children. So if you apply grid properties on the container, you will affect your individual grid children, and the grid children themselves have an awareness of their siblings. Now, the bare minimum to start using grid as a layout tool is to set display to grid, and then you define some columns. So for example, 2 columns, 3 columns. You theoretically don't even need to be explicit about the rows unless you want to, because the row height will naturally be what the content is. Now, if your grid needs to be a little bit more complicated, grid comes with a lot of helpful functions and properties to keep your code neat. So for example, the grid property is a very straightforward way for you to introduce spaces between your grid items. There are also things like the repeat function that can help you dry out your code. For example, if I don't want to type that 4 times, I can do something like this, because it repeats patterns. Another helpful feature would be keywords. For example, if we use autofit in combination with another function like the min-max function. Sorry. You can actually do responsive design without media queries. So if this is something that fits your use case, you don't actually have to do media queries to do something like this with the help of these functions. But another particularly useful feature, which I'm a big fan of, is named grid areas, which you might have noticed in the Spotify screenshot earlier. So after you've set up your rows and your columns, you can actually name specific areas of the grid. You can assign them names. The syntax is quite visual. So the structure of the grid template areas property is a reflection of your grid. So each of these 3 lines corresponds to 3 rows on your layout, and each of the values within the lines are the 2 columns. So I tend to make use of this for designs that need to break at multiple breakpoints, because then all your changes can be isolated on the parent container. So what you do is that you can assign your items to specific areas, like S is side, M is contents, and you don't have to touch it anymore. So let's say I want more columns. I want to add a column to this layout. So let's change some things around. Maybe make that 200. So now I have a 3-column grid, and I need to move some stuff around, right? So how about let's make the header full width, side, content, side. Okay. Yeah. Something's wrong. Side spelled wrongly. Okay, come on. So what this shows is that if you have many different layouts that you need to have at different breakpoints, you can isolate them all on the parent container. Because this is very simple, there are only 4 grid items. But let's say you have a more complicated layout. Maybe you have 20 items. You don't want to have to write media queries, like 4 media queries for each of these items. It becomes very hard to maintain. So I feel that this is pretty helpful for keeping the code very neat and very easy to manage moving forward. But naming grid areas is actually an optional property. I just find it useful. The regular way of placing items is to define its grid row and grid column properties. So I'm going to try turning on the grid inspector so you can see so I'm using Firefox, but all the browsers like Chrome and Safari all have this overlay. So what you can do is you inspect the element, and you can turn on this grid overlay, and it will show you grid numbers. So my image starts from column number 1, it spans 2 columns. My headline starts from column number 2, and it spans until column number 4. So that's how you place items, right? And an advantage of something like this is that it makes overlapping design much more controllable. than any other methods. Like if you try absolute positioning, transforms, negative margins, it's very hard to control, especially across different sizes. But the code I have set up here, I have the middle column where the image and the header is overlapped to be always 300 pixels. So what happens at different widths is that I have a controlled overlap. I feel that what this does is that it makes the layout a lot more resilient at the very extreme width, like at the largest and at the smallest width. It's a lot more resilient with less code. So there's a lot more to grid than I just explained, but this is already sufficient for a very large range of use cases. And the major difference in building layouts with grid versus other layout models is that CSS grid layouts are led by the container. So you implement your layout using a big picture view of your entire grid, and then you place the items on the grid. But the other layout models are focused on the item. So you have to size and you position your item individually. And so it's very different from what a lot of folks are used to. So maybe that's also a contributing factor to why grid is not as widespread. That being said, it's not like you have to use grid for everything. No, grid is just one more additional tool that you can use. Floats are actually still great and relevant for floating content. Okay, and Flexbox is great for handling free space in your layout, and grid is perfect when you need structured rows and columns. But as an application grows bigger and has more features, more components, and more pages, you end up having to adopt some sort of a design system or develop some sort of design guidelines to maintain consistency across the application. So often you have a grid system, and a common pattern for grid systems in front-end libraries like Bootstrap is you generate all the classes that you need for all the widths, potential widths that you have for the sizing of each item in your grid. So this is not even the full. The full is, I don't know, 4,000 lines, right? And to migrate from floats to Flexbox is actually not that drastic a refactor because your sizing still happens on the item. But to migrate to grid is a lot more complicated. So for the sake of discussion, we'll simplify it. We'll assume that we have the luxury of implementing a new design system, no refactoring, and we want to build out the grid system for that. So let's say your designer hands you these specs. Your designer is like, build me this grid with your code, your CSS, or whatever. There are many different approaches you can take to write the CSS to implement this grid in a JavaScript-powered application. So we'll go through a couple of these examples to give you an idea. I'm using React in the examples, but the ideas are transferable to other frameworks as well. So one option is to just write the CSS. So most applications have a global style sheet. You can put the grid styles there. The rationale is that because this grid is meant to inform where everything on your application would sit, it can live in the global style sheet, gets loaded everywhere. And so if I use something like a min-width focused breakpoints, it will look like that. You start off with 4, and then you bump up as in each breakpoint as you require. And then your item placement code, where you want your items to be, can go into the component itself. So if there are common placement patterns that recur very often in your design, you as the person in charge of the front-end component library, you can have pre-written styles, optional but not necessary. So you can do something like this, pre-written styles, and then the people who use your system can use these styles, or they can write their own. So if you're very custom placement, the code would go into your component-specific styles. Another approach would be if you could create container and item components. So this means that your grid code is not loaded in the global style sheet, but it's tied to these components. So if you want to use it, you have to call these components. So the setup is you want to create a column component, a grid component, and then these components are very lightweight. They're thin components. They don't do a lot because all they need to do is be a grid, right? So you have things like, okay, custom class names. You can modify the element tag because honestly, I know React defaults to div, but there are a lot more better HTML tags out there, so please use them. But in general, these are very lightweight, so not a lot of lines, And they don't restrict you from doing custom things because all they need to do is be a grid. So the styles would end up being the same as in option 1 because, but if you're using something like this, you'd probably use something like CSS modules. So your naming convention for the classes can be a bit more casual. Because option 1 had to use BEM for the classes, but with something like CSS modules, you can worry less about the class names, and then your custom code can go into your component styles. Well, I will be upfront about this. I am not the biggest fan of how Tailwind does CSS. The major issue I have with Tailwind is that it sees the cascade as a problem to be solved rather than an attribute to be embraced. But if you use Tailwind the way it was intended, the cascade is almost negated. It's gone. But it's called cascading style sheet, CSS, for a version. So my suggestion is for them to rebrand to Tailwind SS, just cut out the C. That being said, I'm not overly stubborn about this. If my job needs me to write Tailwind, I can still do it the way it was intended, because capitalism. But for now, I accept the reality that there are quite a number of teams that use Tailwind CSS in their applications, and it's working very well for them. So that's great. So if those teams want to use CSS Grid in their application, it's totally doable. Because Tailwind has exposed almost every API for you to modify the default config to suit your custom specs. So the grid specification that we saw earlier can be set up something like this. It's a little bit more complicated, but yes, you can do it. And then you would have to apply these classes to your components accordingly. So maybe there's some way to make it less ugly, but this is the most basic version. And it will be able to achieve the exact same result as the previous two options. So, okay, this is the but does it work. So all the code that I showed you is not fake code, it's real code, because I tested it. So it works. Let's inspect, just to show you that I'm not bullshitting. Layout. So we can see that all the approaches that I discussed, like grid areas, grid template rows, it will work for a very, I would say, sometimes your designers will tell you things, right? Like, I want something to span 5 columns or like 7 columns, and it's not even an even number. But you can do this relatively straightforwardly using grid. And the thing is that even the Tailwind example that I kind of made fun a little bit of, it looks exactly the same. The only thing is you probably won't be able to use the named grid areas. But the point of this example is to show that all 3 approaches can achieve exactly the same result, right? Which brings me to my next point. We covered only 3 options, but there are a lot more possible approaches to implement the grid that we just talked about. Is any of these approaches the best? Are they the correct one? I cannot answer that question because you can't answer that question without taking into account the context in which your code is going to be used. Technically, as I've shown, every approach does the job perfectly. So usually, the difficulty in technical implementation is lower than when you need to consider things around code organization, maintainability, and developer experience, especially for larger teams. Because every organization is different. Some applications have individual teams in charge of specific components. Other organizations could have a few front-end specialists maintaining a component library used by everybody. So the permutations are endless. And company culture also varies between organizations, right? In some teams, engineers have a lot of autonomy. They can make decisions. They can decide, I want to use this, I want to use that. In others, it's a bit more top-down. So sometimes a director who used to code will come in and tell the team, you must use X technology because I like it. Such things are out of your control, and that's okay. But if you do get the chance to influence technical decisions, I find that asking the following questions can help you make a more informed choice that benefits the team in the long term. For example, what are the preferred technologies used in your organization, if any? Usually there is one. It's public knowledge that Shopify is a Ruby on Rails shop. So it's not like we refuse to use anything else. There are projects that don't use Ruby on Rails, but we do need a good reason to deviate from the stack. So from a CSS perspective, because we use Rails, this is going to impact where my CSS code lives. It will impact whether you use a preprocessor or not, how your selectors look like, how much control over the markup you have, and so on. The size and structure of your application will also have a significant impact on how it's organized and how your final CSS will look like and live. How flexible does your design system need to be? Because the more flexible it is, the more complicated your code might end up becoming, because you have to cater for more use cases. So this is where having a closer relationship with the design team can help, because even though a design system starts out from the design team, is like a deliverable from the design team, the success of the design system hinges on the code reflecting what was originally intended. Are there a lot of new developers contributing to your project's code? And what's the documentation culture like? Because these two are related. Because if there are constantly new people onboarded to the code base, you need solid documentation to explain what the expectations are and how things work. Otherwise, the code is going to become very messy very quickly. Maintenance, it's not the most exciting thing in the world, but systems work because someone is maintaining them and keeping them humming along. So who are these people for your team? Is it a centralized setup spread across different teams? What is the skill level of the people on those teams? Like, how good are they at the tech stack? All this needs to be taken account into what you choose for your approach. So my suggestion for decision making is to not look at the pros or advantages of each approach, because all of them have them. Rather, you should analyze the cons, analyze the disadvantages to determine which ones you and your team can accept and live with. And after you've taken all this time to figure out the approach, there's one more very critical thing to do before diving into the fun part of writing the code, and you have to document the why. Because if you were not part of the team who built the application from the start, there are going to be parts of the code base that find you seem weird or like it's odd. Why is this done this way? And instead of being judgmental, I strongly suggest asking why. Why were things done in this way? Sometimes you might find that it was really just a bad idea, right? Someone put something up there because they had a deadline or they didn't know how to do it better. But sometimes you will also discover that there are some constraints, some dependencies, or just a particular situation at that time that was not obvious to you because you were new to the code base and the team. So I know some people don't really want to update documentation. You always hear comments like, oh, our application is so fast, it's so fast that the documentation that I write today is obsolete tomorrow. That's because it's how documentation. Why documentation is different. A paper trail that explains why the way things are is like whiskey. It only gets better with time. So is it possible to use CSS Grid in a large commercial application? From a technical perspective, absolutely yes. But is there a best way to implement it? Well, there'll definitely be a best way for your team to implement it, which will probably be different from the best way that my team does it because of all these factors that we've just discussed. So if you ever get the chance to implement CSS Grid in your project, I want to repeat what Hung said yesterday, is that we would love to hear you share your experience if you can. Because even though your approach is specific to your situation, it might still inspire someone else who is working on theirs. 네, 감사합니다.